Alright, so now I want to cover one more application of this method. So if we ever come across an equation like this in which we're trying to find the zeros of a function and we have multiples of sines and cosines, we have multiples of sines and cosines of the same variable theta, then this method will be useful here. So we can reduce it to an algebraic combination of these functions here, and exactly what we're going to do. We're going to solve for t when we're going to find what value t needs to take to give us a zero of the equation, and then we're going to use that, plug it back into cosine and sine of theta, and we're going to find the point on the circle. And then from there, if it works out that you know the angle measurement that corresponds to that point on the circle, then you can solve for theta as well. So it still involves an inverse trig operation that we're going to go from a point on the circle to theta, but we can do it. Well, I'll show how it's done. So 1 minus t squared divided by 1 plus t squared. So that's the cosine of theta, plus 1 minus t squared divided by 1 plus t squared minus sine squared theta, so 2t divided by 1 plus t squared. Okay, so now we're going to combine these into, we have our common denominator is going to be 1 plus t squared. So for this term, I'm going to write 1 minus t squared times 1 plus t squared. And it's going to be the denominator. So we're going to have plus 1 minus t squared. I'll just go ahead and write it out. 1 minus t squared minus 4t squared, basically. Because 2t squared is 4t squared. Okay. So now this one is going to be 1 minus t to the fourth. So I'm going to multiply all these out into its polynomial, and then we're going to cancel like terms. So I have 1 minus t to the fourth plus 1 minus 2 t squared plus t to the fourth, and then I have minus 4 t squared divided by 1 plus t squared. Okay, so we'll see that t to the fourth subtracts out, cancels. So then we have minus 2t squared minus 6t squared. So it's going to end up being 2 minus 6t squared divided by, okay, well actually, I could have done this earlier, but I could have said, when we got to this point here, this is going to be 0, so it doesn't matter what's in the denominator. The denominator is never going to be 0 because we're squaring t. So we can multiply this out, and we're just concentrated on when is the numerator equal to 0, because that'll still be true. When this is equal to 0, this is going to be equal to 0 as well. So this is the equation we're actually solving. 2 minus 6t squared is equal to 0, or 1 minus 3t squared is 0. Okay, so difference of perfect squares, I have 1 minus the square root of 3 times t, and 1 plus the square root of 3 times t. Okay. So now we have two values of t. We're going to have negative 1 divided by the square root of 3. And then we're going to have the other value, 1 divided by the square root of 3. Alright, so this one is when this is 0. So 1 plus the square root of 3 times negative 1 times the square root of 3 is 1 minus 1. So that ends up being 0, so that makes this term 0. In the other case is 1 divided by the square root of 3. The square root of 3 divided by 3 is 1. 1 minus 1 is 0. So the two cases that make that 0 are here. Okay, so we can rewrite this as, so if I multiply the top and the bottom by the square root of 3, I'll have negative square root of 3 divided by 3. And the square root of 3 divided by 3 for that side. All right. I'm going to get myself some more room up here. Oh, I erased the original problem. Okay. I think the original problem was 0 is equal to cosine theta plus cosine squared theta minus sine squared theta. And so we did our t substitution here, and we got these two values for t. Okay, so now I'll plug in cosine theta. Is going to be equal to 1 minus t squared over 1 plus t squared. So 1 minus, we'll just solve for this one, square root of 3 divided by 3, 1 minus t squared over 1 plus t squared. Okay. So squaring this, I'm going to end up with 3/9, so 1 minus 3/9, and same here, 3/9. So 1 minus 3/9 over 1 plus 3/9. I'll just write it over here actually. So 1 minus 3/9 is 6/9, which is 2/3, divided by 1 plus 3/9 is 12/9, which is 4/3. So 2/3 divided by 4/3 is going to be 1/2. Right? So we know cosine of theta is going to give us 1/2. Okay. What about the other case for negative? The negative case. Well, let's solve for the sine theta first, and we'll do the negative case. So I'll say this is for t is equal to square root of 3 divided by 3, and then sine theta is going to be 2 times the square root of 3 divided by 3 divided by 1 plus the square root of 3 divided by 3 squared. Okay. So that's going to end up giving us 2 times the square root of 3 divided by 3 over, remember this was 4/3. Or in other words, this is 1/3 divided by 1/3 is going to cancel, divide out, and then we have 2 divided by 4, so it's the square root of 3 divided by 2. Alright, so this is 1 point, so we know sine theta, cosine theta, or cosine theta, sine theta is going to be 1 square root of 3 over 2. So that's 1 point along this curve that I know that it's going to give us a value, so it's going to be the point right here. So let's say that's P1, that's our solution. We know for t is equal to, for that we have 1/2 square root of 3 divided by 2. And we know that this point actually corresponds to the theta is equal to pi over 3. In other words, if I plug in pi over 3 to sine of theta, I'm going to get square root of 3 over 2. If I plug in pi over 3 to cosine theta, I'll get 1/2. So this point corresponds to the angle measurement that solves that equation there. Alright, and similarly with the negative 3 divided by, negative square root of 3 divided by 3, we could show that as well. I'll just, how much time is this? It takes 9 minutes. Well, alright, fine, I'll just do it. Square root of 3 is equal to negative square root of 3 divided by 3. So I know that the cosine of theta is equal to 1 minus negative square root of 3 divided by 3 squared, and that's 1 plus negative square root of 3 divided by 3 squared. So if you'll see, the cosine theta is actually going to give us the exact same. It's going to be 1/2. That's because even though this is negative, the negative squared gives us the same answers there. So what's going to change is our sine of theta. Sine of theta is going to be equal to 2 times negative square root of 3 divided by 3 all over 1 plus negative square root of 3 divided by 3 squared. All right. So this one's going to give us negative square root of 3 divided by 2. And we know that because the only thing that's changed between there and there is the negative. So we know it's going to be negative. So the next solution is going to be this one right here. See, that's P2. And the corresponding theta value to that for P2 is negative pi over 3. So those are the two thetas that we can plug in that will solve this. And also, actually, there's many more solutions because we can always add 2 pi to each one of those, or subtract 2 pi from each one of those for P2. And it'll give us infinitely many solutions that solve this equation. But if we're just paying attention to the solutions between negative pi over 2 to pi over 2, we'll have those two solutions, P1 and P2, which have corresponding angles. And those are the pi over 3 and negative pi over 3. Okay.